Okay, in this video, I'm going to be covering a few of the problems from section 4.2. Um, let's just start with 4.2, number 1. So we have here x minus y plus z is negative 4. And then we've also got 3x plus 2y minus z is 5. And then negative 2x plus 3y minus z is 15. So we're trying to solve the system of equations for x, y, and z. So what I am going to do here is do elimination. Substitution doesn't work very well for 3 variable equations. So we're going to do elimination here. And basically the idea that you're going to do is you're going to just look at 2 equations at a time and eliminate one of the variables. So if I kind of look, I have a 1 in front of this x. That's a pretty nice thing to use to eliminate other things. So let's eliminate x out of these 2 equations here. But I'm just going to focus on that middle one for right now. So I'm just going to eliminate x out of this one right here. Okay, so how am I going to do that? How can I get rid of 3x? Well, from this guy, I would need a negative 3x to cancel out with that 3x. So I'm going to times the top equation by negative 3. Times by negative 3. Okay? And so when we do that, we get negative 3x plus 3y minus 3z is 12. And then we've got 3x plus 2y minus z is 5. Those are my 2 equations. I'm going to add those 2 together to get rid of the x's, right? The x's cancel out. We get 5y minus 4z is 17. Okay? So that's one equation that we got just by eliminating x's by using the first and second equation. Okay? So we eliminated x. We now have an equation with just y and z. Okay? So in order to solve this, I need another equation with y and z that I can combine with this one to be able to solve it. Okay? So what I'm going to do is I'm going to eliminate x. I haven't done anything with this third equation yet. I'm going to take that and I am going to eliminate x with it. Okay? So to eliminate x, I need to times this top one by 2 so that it will cancel out with that negative 2x there. So 2x, I'm going to times that top equation by 2. So we get 2x minus 2y plus 2z is negative 8. And our other equation was negative 2x plus 3y minus z is 15. Okay. I'm sorry, the glare there. I'm going to turn that away a bit. Okay. So now I just add those 2 equations together. And what happens when you do that? Well, the x's cancel out just as we wanted them to. And we get y there and a z there is 7. Y plus z is 7. Okay. So I have eliminated x in this third equation, and I am now ready to solve a new system that I just made. I eliminated x out of 2 equations, so I now have 2 equations, one here and one here, with 2 unknowns. So I can now kind of set up a new system. Y plus z is equal to 7, and 5y minus 4z is 17. Okay, this is my new system of equations that I'm going to solve. It only has two variables now, so we took it down to a two-variable problem instead of having to deal with all three variables at the same time. So what I'm going to do is I'm going to do elimination again to solve this system. Okay, so what I'm going to do is I'm going to take this top equation to get rid of y. I'm going to times by -5. Times by -5 through the whole thing, that top equation. So we get -5y minus 5z is -35. And so we get 5y minus 4z is 17. So we're going to add those two together. And we get the y's cancel. We get -9z is 18, -18. And so then I just divide by -9 on both sides, and we get z is 2. Okay. So I found one variable, right, from this. And I had to do basically 3 eliminations to get there, right? I eliminated x out of this equation, this 3x minus or plus 2y minus z is 5. We eliminated x out of that, and then we eliminated x out of this last one to get 2 equations with 2 variables, which we then eliminated y out of to find z, right? So we got z. Now all we have to do is find y and x, okay? So what I'm going to do with the z, and I'm running out of space, so I'm going to have to get a blank board here. Once we have z, we can plug that into one of the equations with just y and z to figure out what y is. So I'm going to take my z, and it doesn't matter if you plug it into this one or this one. They both just have 2 variables in it, so I'm going to plug it into that one right there. Okay, that's what I'm going to do. And so when I do that, I'm going to maybe remove this off. Get some more space here. Plug that back in. So z equals 2, so we get y plus 2 is equal to 7. So then to solve for y, we just subtract 2 on both sides. So we get y is 5. Okay? And now that we have both y and z, I just need to find x. So that's where I would go back to one of my original equations, and it doesn't matter which one. I'll maybe bring them up again. One of my original equations out of these 3, I'm going to plug in y and the z that I found right here. I'm going to plug those in to one of the equations and find x. So one of the equations I had from the very beginning was x minus y plus z is -4. It doesn't matter which one you use. So let's just use that one. So when I plug in y is 5 and z is 2, okay, I can figure out what x is. -5 plus 2 is -3. And then we just add 3 on both sides, so we get x is -1. So our final answer here is -1, 5, and 2. That's the point where these planes intersect. Because in 2-space, we were dealing with intersections of lines. When we have 3 variables, we're going to be intersecting planes. So that's where all 3 of these intersect, that point. Okay. this is generally kind of the pattern that you're going to be following on all of these. There are a few deviations from this, I guess you could say. I'll do just one more problem for you. If whenever you're doing the elimination stuff, if you ever get a like 0 equals 2 or something like this, where you have a number equals another number and they're not actually equal, this always means that there's no solution. Okay, so if you ever get something like that when you're doing elimination, there's no solution. If you get something like this, like 0 equals 0, that means the planes that you're dealing with are actually the same plane. Planes are the same. Okay, they intersect everywhere. So I'll show you an example of that real fast. That would be number 7, I think. No. Yeah. Number 7. Okay, so the equations it has are x minus 2y plus z is -5, and then -3x plus 6y minus 3z is 15, and then 2x minus 4y plus 2z is -10. So if I go through that same process I just did on that last problem, and I do it for this one, what happens? Well, again, I'm going to eliminate a variable from 2 equations, and if you do, on some of these, there's already a variable eliminated from one of the equations, so you can just use that as your, like, one of the equations in your 2 variable example. But like in this one, all the variables are in all the equations. So like if there wasn't an x here, for instance, I would use this equation as one of the equations when I solve for when I do the elimination. Let's see, let's pull it up here. Like on the last problem, we made this system with 2 variables, right? So if I had started with something like this, I would use one of those as one of those equations, and I would eliminate x from the other 2 equations to use as the other equation, okay? But this one has all the variables there, so there's nothing really nice that we can do with that. So we've got x minus 2y plus z is -5. So what I would do here is I'm going to try and eliminate x, and you could do y or z as well, but x seems like a fairly nice one to do. So I'm going to times this top one by 3 to make it cancel with this -3x right there. So we get 3x minus 6y plus 3z is -15. And then we've got -3x plus 6y minus 3z is 15. Now what happens when we add those 2 together? The x's cancel out, but also the y's cancel out. The z's also cancel out. So we just get 0 is equal to 0 here. Okay. So what does that mean? It means that these 2 planes, the 2 that I was combining, these 2 right here, those are actually the same plane. Okay, they have exactly the same points on them. Okay, so one last thing I should check here is that we know that these 2 planes are the same, But what about that third plane we have right here, this guy right here? Let's try and eliminate x using these two again and see if those are the same. So I'm going to take that top equation to cancel out this 2x here. I'm going to need to times this by -2. So I'm going to times that by -2. So we get -2x plus 4y minus 2z is -10, or sorry, 10, positive 10. Okay, and then we've got 2x minus 4y plus 2z is -10. And we add the two together. Everything cancels, so we get 0 equals 0 again. So what does that mean? It means that this plane is the same as this plane, right? So all three planes are actually the same plane. So the solutions are just all the points on, it doesn't matter which one of them I use because they're all the same plane. So my answer would look like this. You're taking all the points, x, y, and z, okay, such that you're on one of those planes, right? They're all the same plane. So you can just write x minus 2y plus z is 5. And then curly brackets there. Okay? So this is just the set of all points on the plane. Okay? So that happens if you get like a 0 equals 0 sort of thing. That means the planes are the same. If you run into like a 0 equals 7, 0 equals 5, that just means there's no solution. There's no points that they share in common. So hopefully that kind of gives you a starting point with 4.2. Can I kind of help you start to get going there? Let me know if you have more questions. I'm sorry I don't have more time, but I will talk to you later.